The influence of the shape of individual grains on the mechanical and physical properties of granular materials is a subject of intensive research. Various numerical and experimental studies have already been conducted, for example, direct shear, angle of repose, and triaxial tests. The problem is that numerical models have to be verified with experiments. However, the natural grains have random geometry, which makes the characterization of every grain almost impossible and the experiments hard to control. In this study, different molding and additive manufacturing technologies have been investigated to produce radial ballast grain analogues with controlled shape. With using artificial grains in the experiments, it becomes possible to conduct the test several times on assemblies that consist identical grains. Also, the results will become more comparable to numerical simulations because we know the shape of each individual grain, so we can precisely simulate the experiment. Specimens have been prepared with the use of 5 different technologies from 17 different materials and uniaxial compression and 3-point bending tests. The uniaxial compression strength, flexural strength, the compressive modulus of elasticity, and the flexural modulus of elasticity were measured, and the fracture mode of the samples were qualitatively evaluated. Then the mechanical properties of artificial materials were compared with the properties of typical radial ballast materials in Hungary. These are andesite and basalt. Of the additive manufacturing technologies, the PolyJet and multi-jet fusion technologies produced specimens with the closest mechanical properties to andesite and basalt. Furthermore, we recommend the use of polyester resin mixed with fine-graded crushed stone aggregate or the application of ceramic powder of the molded materials.